Greetings, my wonderful scholars. I'm Mr. Okafor, PC, your online physics teacher. Our topic of discussion today is the concept of work, energy, and power. The concept of work, energy, and power. Okay, before we start today's discussion, I would love to ask you a question. Do you think human beings die? Do you think human beings ever die? The concept of work, energy, and power has answers to this question. However, I would like to begin with the concept of energy. I will be starting with the concept of energy. What is energy? But before we go into the definition of energy, I would like to give you a clue to the answer. I would like to give you a clue to the question I asked earlier. If humans actually die, then I will tell you that human beings do not die. Human beings do not die. Stay tuned. In the course of today's lesson, you will see reasons to believe with me that human beings do not die. Energy. We'll go back to energy. Energy, recall, physics is concerned with our natural world. Our natural world comprises of space and matter. Space and matter. Space. And space is filled up by matters in diverse states, be it solid, liquid, or gas. Every matter comprises of energy. There is no matter void of energy. No matter can say, oh, I don't have energy. It's not true. We can even take matter to be energy. Matter is synonymous as energy. Another name for matter can be energy. Every matter is comprised of energy. Energy is a property possessed by matter. And the surprising thing is, energy is found in matter and is also distributed by matter. Energy is both possessive and distributive. No matter can keep all its energy to itself. Matter keeps energy and also shares energy. Why? Because all matters in space interact via energy. It's energy that permits interaction in matters. Take for instance, the teacher standing before you is matter. You as a listener is also matter. You possess energy. I also possess energy. But if we must interact, we also do what? Share energy. It's energy that connects everything in the universe. For instance, sound energy is what connects two of us as teaching and learning processes occur. The teacher creates sound energy and is being taken to the learner. Likewise, light energy. That's why I have pictorial view of today's lesson. These are two examples of energy. Sound energy, light energy. That is what at least two energies that connect the teacher and the learner. You cannot believe with me that energy is both possessive and distributive. And energy permits all matters in the natural world to interact. Human beings do not die. In energy, there are diverse forms. There are diverse forms of energy. We have mechanical energy. Mechanical energy is subdivided into two: potential energy and kinetic energy. Mechanical energy is subdivided into two: potential and kinetic. Okay, before I take you to diverse forms of energy, let me now give you definition for energy. Energy is a property in matter. Energy is a property in matter that is both possessive and distributive and allows interaction of matters in space. Energy is a property in matter which is both possessive and also distributive, thereby allowing interaction of matters in space. At this point in time, we're both the primary school definition that says energy is the ability to do work. Yeah, every matter can do work. Every matter can be harnessed to do work. It is correct, but we've gone beyond that level. Energy at this point can be said to be a property possessive and distributive, which permits interaction. Interaction of one matter and another can also be called work. Okay, we can now go back to the forms of energy. The first one is mechanical. When any matter is at rest or in motion, it possesses mechanical energy. This is why we have two subdivisions: potential mechanical energy, kinetic mechanical energy. Potential energy, simplified or contracted as PE, kinetic KE. Then mathematically, you understand better what potential energy is saying. Because most learners have a kind of misconception that potential energy is due to rest. But that's not the main task that is achieved in potential energy. That's not the main motive of potential energy. Potential energy is actually due to height. Then the height can bring about rest. It's also due to mass. And the mass can also bring about what? Rest or rest position. So the key thing in potential energy is mass and height, as we see in the equation. Okay, notice. Potential energy varies with mass and height because G is a constant for a particular planet. Take the Mother Earth, for instance. The G is a constant, 10 meters per second square. Anybody, when you get a body, example, a car. Let's take car company for example. Car company, the target of all cars is to move. The target of a car to move. When the potential energy of a car is increased beyond the engine of the car, then it brings about rest position. It affects the motion of the car. So all car companies are conscious of mass and height. The more mass the car has and the more height the car has, the greater the potential energy, and it can bring about rest effects. So being at rest is just an effect, but we're concerned what causes the effects. So the two variables in potential energy are mass and height. It's energy due to mass and height. The higher the mass, the higher the height, the higher the potential energy. The smaller the mass, the lower the height, the lower the potential energy. Take for instance 2 men. If we have 2 men, okay, let's make mass constant. Okay, we can't make mass constant because the height will vary with the mass. If we have 2 men, one is massive and tall, and the other one is less massive and short, the man with greater mass and height has a greater potential energy. So the energies are unequal. The energies are unequal. That's why most times in wrestling, you see men that have similar masses coming together to wrestle so that the energies can be matched. When the mass increasing and the height increasing, the potential energy is doing what? Increasing. And when the mass and the height go down, the potential also do what? Goes down. So potential energy is energy due to mass and height. These are the two key variables. And a constant acceleration due to gravity. And these variables now determine what happens to the potential energy, and that is direct variation. They go in the same direction. Up together, down together. Then we'll go to kinetic energy. Kinetic energy is due to speed. You can see better in the equation. Half mv squared. Anybody that has a greater mass and a greater speed will have a greater potential, will have a greater kinetic energy. The key variable there is speed. When the speed of a vehicle is increasing, its kinetic energy is increasing. That is why it's not allowed for pedestrians to use carriageways, expressways, because vehicles on the expressways go at a very high speed. And if collision should occur with a pedestrian, huge amount of kinetic energy will be transferred to the pedestrian, which can cause loss of life. Kinetic energy, due to be cautious, be careful with things that have high speed and high mass. They have high kinetic energy. High kinetic energy. Imagine a rock falling from the sky or from a mountain top, and it hits your head. You are finished. Your soul will depart from your body because of kinetic energy. This is why in the ancient time, one of the great weapons of Roman Empire was getting heavy rocks at high mountains. When the enemies begin to pass through their path, they can push the rocks down to kill their enemies. When rock is falling down, the speed is increasing. Therefore, the kinetic energy is also doing what? Increasing. Energy. Energy. Every matter has energy. No matter is void of energy. Everything around you has energy. It's possessed in those matters. Therefore, those matters can also be called energy. And there are diverse forms of energy. So we'll continue. We've mentioned mechanical and its subdivisions. We'll go to chemical energy. Chemical energy is the energy in me and energy in you. Food substances we take have chemical energy. That is why I'm able to teach and you're able to listen. When we eat, we derive chemical energy. We also see chemical energy in batteries. Our phone batteries and our laptop batteries. Chemical energy. Every matter around you has energy. We go to electrical energy. This is the energy, this is one of the most used energy. Energy we use to recharge our phone, power our television, our refrigerator, and our home electrical appliances. This energy is due to movement of charges in the atom that makes up a matter. Every atom comprises of electrons, and these electrons, when they move, they bring about electrical energy. Movement of electrons with respect to time brings up energy known as electrical energy, and is the most harnessed energy in our society. Okay, we also have nuclear energy. This is deep-seated in the nucleus of an atom. Any nation that has nuclear energy has power. This the most powerful energy at the moment. Nuclear energy. The energy that puts matters together. The energy that assembles atoms. The energy in the nucleus of an atom. This energy can be harnessed at least in two ways. Nuclear power plants and nuclear bombs. Nuclear energy is the reason why Russia and America are feared in the world. Any nation that has nuclear energy has power. Power. Because the biggest of energy is in the nucleus of an atom. Nuclear energy, a great energy. We also have solar energy, energy coming from the sun that powers day-to-day activities. Every morning, human beings begin to move helter-skelter in search of vital needs for survival because the solar energy permits such. Light coming from the sun, heat coming from the sun, all can be attributed as one solar energy, energy from the sun. And this solar energy can be harnessed in a photovoltaic cell, popularly known as solar panels, to power our home electrical appliances. Solar energy, energy from the sun. We have wind energy, wind, water energy, energy from water and wind. All matters are comprised of energy, irrespective of the states of matter. No matter is void of energy. We also have sound energy. Sound energy like the one we're using now. Sound. We also have biomass energy. Biomass energy is energy in living things, both living and non-living. Plants, animal remains, decayed organic matter, all these are also energy, biomass energy. And they can bring up other forms of energy like heat. Biomass can also generate heat. We also have heat energy, thermal energy, all kinds of energy. We also have geothermal energy. Even the earth has heat. Listen to the name, geo for the earth, thermal, heat. Even the mother earth, deep towards the core of the earth, we have tremendous amount of heat that can be harnessed to generate electricity. We can harness the heat from the earth, use the heat to heat up water, convert it to steam, and use the steam to turn turbines, and use the turbines to turn generators to bring about electricity. The beauty of energy. In order to understand energy better, we have to go to the law known as the law of conservation of energy, which will put an answer to my earlier question. And the law of conservation of energy states, energy can neither be created nor be destroyed, but can be converted from one form to another form. Please pay attention. Energy can neither be created nor be destroyed, but can only be converted from one form to another form. Paying attention. This interpretation of this law. Human beings do not die. Human beings will represent matter, will represent energy. We can never die. We cannot be destroyed. We cannot be created. What do? When humans die, there are two things involved. It's either we are buried or we are burnt. Cremation. Depending on the cultural values of a community. When humans die and humans are buried, they begin to, with number of days, the dead bodies begin to decay. The carcass begin to decay. And when humans decay, they turn to nutrients, humus. The soil assimilates the nutrients. When the soil assimilates the nutrients, the soil becomes fertile. And when the soil becomes fertile, the plants, the available plants or seedlings absorb the nutrient from the soil and turn to tree or flower. The plants absorb it to grow. And when the plants or the tree grows, it yields fruits. And these fruits can be eaten by living organisms. And the living organisms gain energy. And when the living organisms die again, they join the cycle once again. We're just cycling. We're cycling. We die. We decay. We're assimilated by the soil. The plants assimilate nutrients from the soil. the plant gives food again or energy again. Living organisms feed on the energy, and with time they die again. Cycle. We do not die. We do not die actually. We cycle. We change form. We change form. For now, we're in the form of a person. Time will come, we'll go into form of humus, form of tree, and form of apple, pineapple, orange, mango. Yeah, this one nature does with us. Cycle. Nature is cycling us. We don't actually die. Why here? Energy can neither be created nor be destroyed, but can be converted from one form to another form. Anytime you get heap of clothes that you are no more using to burn them, you are doing energy conversion. You are not killing those clothes. You are converting your heap of clothes to gases. To gases. And funny enough, you inhale those gases back. Some of them stay in the environment. This is why the world is conscious of energy conversions, because we've done researches to notice that some of these conversions are not beneficial to us. So those ones that are beneficial to us will support it. Those ones that are not beneficial to us will make law to prohibit the conduct. This is why every society is against bush burning. When you convert your grasses to gases, then you ask yourself, is it better to have grasses that make the soil fertile, or to have gases that affect human health and materials around? Energy conversion. One part is beneficial, the other is not beneficial. Stop bush burning. The energy conversion is not suitable for survival on Earth. That's why there are laws on bush burning. Stop burning clothes. Stop burning refrigerators. The gases affect the ozone layer. Energy conversion. We either make our Earth or mar it. We have to be conscious of energy conversion. It can either be beneficial or not beneficial. Energy conversion. This is why some energy conversions are not permitted. The world is thinking on tilting away from internal combustion engines that burn petrols or crude oil byproducts into gases, that convert crude oil byproducts into gases like carbon monoxide, because it pollutes the environment. While targeting tilting to solar engines, wind engines, water engines, or any other green energy that is environmental friendly or environment friendly. We are targeting harnessing energies that are friendly to environments and tilting away from energies conversion that pollute our environments. This is the beauty of science. This is why we need to study our natural world, because our ignorance mars us. So we need to be knowledgeable to know what benefits us in nature. Energy conversion, very crucial. Okay, the question becomes, what is the connection between energy and work? A very simple connection. Energy and work are synonymous. Energy is work, work is energy. The only difference is this: you can convert work completely into energy, but you cannot convert energy completely into work. Please pay attention. All work is energy. All work is energy, but all energy is not work. All work is energy, but all energy is not work. You can convert 100% of work into 100% energy, but you can never convert 100% energy into 100% work. It's not done. In every conversion of energy, there must be some amount of useful wastes. This is the second law of thermodynamics. In every conversion of energy, there must be some amount of useful waste. Take for instance, if you have a mango tree in your compound, I bet you and your community can never eat all the mangoes from the mango tree. It's impossible, because you are converting the energy in the mango tree into chemical energy in your body. So there must be some amount of useful waste. Some of the mangoes will fall to the ground and decay and add nutrients to the soil. Some will not even germinate well. Some will be eaten by birds. Some will rot on their own. There are processes happening on the tree that will hinder you from taking all the energy from that tree, or all the energy from the mango. Just focus on the mango, all the mangoes on the tree, to yourself and your community. It will be highly impossible. You must give out to the environment that brought about the growing of the tree. You can't take everything. The environment contributed, so the environment must take some to itself. The beauty of nature. Energy is distributive, not only possessive. You cannot possess all the energy from your mango tree. It's impossible. In that conversion of energy, some amount of the energy must be wasted. We call it useful waste, because actually it's not waste. Mango, going back to the environment, is adding to the nutritious contents of the soil. In every conversion of energy, there must be some amount of useful waste. So work can be completely be called energy. All work can be converted to energy, but all energy cannot be completely converted into what? Work. Let me give you another instance. A car. Car's internal combustion engine. When you buy petrol, that is energy. You cannot convert all the energy in the petrol into useful work in the engine. It's impossible. This is why every car has exhaust pipe. Some energy must be wasted through the exhaust pipe. If you have 100% work, 100% energy, about 70, 60, 50, or 80 thereabouts goes into useful work. Why 20%, 30% go into useful waste? This is why every car has exhaust pipe. Take humans for example. Why do you think we have anus? Because we cannot convert all the energy in our food into useful mechanical work for our day-to-day activities. Some must go through your anus. You must waste some energy in accordance to the logic that says that in energy conversion into work, converting energy into work, there must be some amount of useful waste, and this is the core difference between energy and work. All work can be converted into energy. All work is energy, but all energy is not work. But outside this difference, work and energy are the same. They have the same formula, the same units. Both are measured in joules. Both are measured in joules. SI, or fundamental units of energy or work, is joules, in honor of Prescott Joule, a great scholar whose value in energy researches cannot be neglected. Prescott Joule. Okay, so let's now tilt better into work. In the physical world, there are three conditions for work to be done. There are three conditions for work to be done. Number one, in work, force must be applied on the body. That's the first condition. Force must be applied on the body. Second condition, when force is applied on the body must cover some distance. That's the second condition. When force is applied on the body, that body must cover some distance. It must change position. Then the third and the most important condition or criterion, when force is applied on the body and the body covers some distance, the distance must be in the same direction with the applied force. The most important of it all. The body that absorbs the force must move in the direction of the applied force. Take for instance, let's say I have a football and I kick a football in the forward direction. The football is meant to go in forward direction because the force causes the movement of the football. So if the force is going in the forward direction, the football must follow suit in accordance to the most important criterion for work to be done. Then in a situation I kick the football forward and the football goes backward. Hey, my other name becomes Ben Johnson. I will take off because something unique happened or something metaphysical happened. And what is that? Maybe my ancestor kicked the ball back to me. Maybe something else, an invisible being, ghost, spirit, anything there, kick the ball, or a physical activity resulted to that, like wind. When you play in a windy weather, something may occur. When you kick the ball, the wind can pull it back. Most especially in the game of table tennis. So it's expected that anytime you put force on the body will go in the same direction with the what? Force. Forward kick, the body goes in forward direction. Backward kick, backward direction. The situation you do forward and you get backward. Metaphysical. Is beyond physics. Something happened, something spiritual has happened. Or you look well to see if it's a physical phenomenon that occurred. But take notes. For work to be done, the most important criterion is that the force put on the body, making the body to change position, the body must be in the same direction with that applied force. These are the conditions for work to be done. And this explains why a person carrying luggages on the head or on the hand and moving about is doing no work. If you like, carry rocks, plenty rocks on your head, and you are sweating and dying, but provided you are moving, you are doing no work in the physical world. Why it appears as if you are doing work is because internal work is done in your muscle. Your muscle contracts and relaxes, generating heat on your skin, generating heat in your body and sweating. and causing you sweat on your skin. So no work is actually done if you carry something on your head and you are moving. And I will tell you why. Record the condition for work to be done. The moving body and the force must be in the same direction. If the force is going this way and the moving body is going this way, in the same direction, work is done. A situation whereby this is force, this is distance, or you can put them on the same line. Force, movement of the body, distance covered by the body, work is done. Force, distance covered by the body, work is done. They are going in the same direction. Then when you lift up anybody, take for instance, lifting up a seat, you are doing work. Why? Because you are lifting up. Lift involves going up, and the seat also goes up. So the seat goes in the same direction with the what? Force. Then taking the seat down, you are doing work. Taking down implies going down. Then the seat also goes down, you are doing work. Then lift up the seat, you've done work. Then begin to move with the lifted seat. You do no work. You are doing no physical work. No physical work is done. And let's see why. This is the ground. This is the lifted seat. Lifting it up, work is done. Then moving with it. When you begin to move with the seat, lifted seat, you are moving with it in this direction. This is the distance covered. Then you are no more taking the seat up and not taking it down. You've lifted it up and the work ended there. Then the force that begins to pull it is force of gravity. Force, which is what? Gravity. Then distance covered. Then observe something. Anything lifted up, gravity is pushing on it. That's why you feel the weights. That's why when you carry heavy things, you feel like dropping it on the spot. Because something else in the environment is pushing that is gravity. So gravity is pulling on the lifted seat and you are moving this way. Then the force and the distance covered is perpendicular. Therefore, no work is done. The force and the distance covered is perpendicular. They are not moving in the same direction. Therefore, no work is done. So take note, anytime we lift things up and begin to move with them, you go to airport, carry your luggages, lift them up, and you are moving about, you are doing no work. Because gravity pulling on those luggages, and you moving on a horizontal plane, the force and the distance covered are perpendicular, therefore you are doing no work. But there is internal work in your body system due to contraction and relaxation of the muscles. Please take note of that condition. There are 3 conditions for work to be done. Force must be applied on the body. The body that absorbs the force must change position. The change in position must be in the same direction with the applied force. Recall, no matter is void of energy. No matter is void of energy. Energy is possessed and is also distributed. Recall, energy permits interaction. Energy permits interaction of matters in space. Thank God for energy. That's why we know there are distant stars. Light energy. If not for light energy, human mind will still be in ignorance. Light from distant stars enlightened us. We begin to wonder, what are they? Who are we? Where are we? Energy. Light energy. Light energy. It's sharpening the human mind. It's sharpening the human mind. If stars are there, that means we must be a greater being. We must be in a great universe. There must be something else there. Light, energy, interaction. Permitting interaction of diverse matters irrespective of distance. Energy permits interaction in space. Energy permits interaction within matters. Energy. Then the question becomes, okay, how does energy link to power? How does energy and work link to power? But do not forget that work done, the formula is gotten from the criteria for work to be done. Work done is simply force times distance. Where W stands for work done or work or energy, F for force times distance. And the SI unit of all energies and all works, joules. Joules. Okay. This is for finding work done. Force times distance. The units can also be Newton meter. 1 Newton meter, Newton for force, meter for distance. 1 Newton meter is the same as 1 joule. Okay, we'll go to power. Power. The idea of energy or work will be incomplete if the concept of power is not introduced. Power. When energy begins to flow, because energy is meant to distribute, it's meant to be distributed, pardon me. Energy is meant to be distributed. When energy begins to flow in the environment, the name ceases to be energy. It attains a new name, power. Power is energy flowing with respect to what? Time. When that energy begins to flow, it's no more called energy. It's not just a new name, power. Power is energy over time. Power. Power is work done over time or energy over time. Time indicates flow. The idea of power explains better what happens in a natural environment with respect to energy. Take for instance, let's have two examples, postal office and GSM phone. We want to compare the power in these two things. Post office or postal office and GSM phone, they target the same energy. The energy is just to have message and to pass the message from one person to another. Post office and GSM phone have the same energy. We now want to compare their power. So that you can understand the idea of power. So in post office, let's take another example. We have a mother whose husband is sick, and the mother wants to reach the son at Lagos. Let's say the mother is in East and wants to reach the son at Lagos, relating to the father's health. In those days, in ancient time, when post office was in high demand, the mother would put to writing, "My dear son, your father wants to see you, he's sick." Then, and so many other contents. The mother seals the message. The mother goes to post office in the East and posts it. The post office receives the message. Then they take record of the message. Then the post office calls their courier service man who will send it from East to Lagos. Maybe this has taken 2 days. Maybe it has taken 2 days before it gets to Lagos. And the courier service man goes to their branch in Lagos, another post office, and posts it. Then the post office in Lagos will now call their own courier service man and also send a letter to the final destination, maybe 3 days, 2 or 3 days thereabouts. Then when the letter gets to the son, finally, the son can now assimilate the contents of the letter. Message passed in 2 or 3 days. Postal office. Then see the beauty of GSM phone. The same message, just click on send. The same message is sent in 1 second. Then the question becomes, the same work, post office, GSM phone, same work done in various time. One is 3 days, the other one is 1 second. Which one is more powerful? The idea of power is the idea of more energy done in little time. The idea of power is the idea of more energy used in little time. If you can move from Lagos, or if you can move from Lagos to East, Anambra State, for example, in 1 minute or 1 hour, you have power. If you happen to do it running 100 meters in just 1 second, you are God of speed. You are flash. You cover that distance of 100 meters just in 1 second. You are the God of speed. It has not been attained in the record of mankind. You are flash. This is why the most powerful when it comes to speed is light. Light covers 300 million meters just in 1 second. This is the fastest matter for now in the universe. The idea of power is idea of more energy used or exhausted in little time. Power. Then we cannot build up the logic. Remember, we don't create formulas in physics. Let's make it logical and form the equation. See how this equation was derived. Power is inversely proportional to time. The smaller the time, the more the power. Little time, bigger power. The longer the time, the smaller the power. Longer time, little power. If it takes you hours or minutes, plenty of minutes to do house chores, you are less powerful. But if you can do a clean house chore within a short time, you are powerful. You are powerful. Take for instance, we have 2 students sweeping different classrooms of the same size. Yeah, we want to create idea of the same energy. So the classes size are the same. Then let's take lockers and seat away. They both have equal datiness. Both have debts, equal debts in the classroom. We provide them with the same sweeping agents. Then we now observe them. We've made the same energy available to them. We now get two students to know the person that has a greater power. Then if both of them also do clean job, the clean job is constant. You can confirm that both have clean job. Then we now take their time and notice that the first student does his own in 5 seconds. 5 seconds. Second student, 15 seconds. 15 seconds. Then let's now say that the energy is 30 joules, it's constant. Then energy or work, 30 joules. Then let's see the student with a greater power. The first student 5 seconds, second student 15 seconds, energy 30 joules. Let's know the student that has a greater power. Recall, if the mathematics goes against the logic that formed the equation, we are wrong. Okay, let's go. Let's go mathematical. Okay, for the first student, the power, work done over time. The work is 30 joules. The time is 5 seconds. 30 divided by 5, 6. Then the unit of power will also be derived from the formula. Work is joules over power. Time is seconds. So the first student has power of 6 joules per second. 1 joule per second is called 1 watt. In honor of James Watt, a great scholar whose research on power cannot be neglected. James Watt, one of the contributors of steam engines. Okay. Then we can now replace this 1 joules per second with 1 watt. So this can also be 6 watts. 6 watts. The first student has power of 6 watts. Let's see the second student. Work done over time. The work is constant, 30 again. This time, second student does work in 15 seconds. Then the power becomes 30 divided by 15, 2 watts. Then let's go back to the logic. The shorter the time, the higher the power. The student with 5 seconds, power of 6 watts. The longer the time, the smaller the power. The student with 15 seconds has 2 watts power. My dear scholars, if we must be powerful, we must learn to do great things in little time. That's the idea of power. In summary, recall, humans don't die. Recall, no matter is void of energy. Recall, energy is both possessive and distributive. Recall, energy permits interaction in the world, in the physical world. Recall, when work is said to be done, there are 3 criteria. 1, force must be applied. 2, the body that absorbs the force must cover some distance. 3, the distance covered must be in the same direction with the applied force. Recall, the higher the power, the little the time. Thank you. Remain on this platform as we go on to demystify the nature of physics. Stay tuned. God bless you.